I'm Anil Kumar. In this particular video, we are looking into the number of triangles which can be formed from given information. The question here is, for each question, identify if 0, 1 or 2 triangles could be formed using the given information. Solve the possible triangles. So we have two parts to this. First part is we have to only find out the number of triangles which can be formed. And the second part is solve the triangles which can be formed, right? Now the concept here is that to solve any triangle, what do we need? To solve any triangle, we need three things. Now these three things are normally combination of angles and sides, right? So that is what we need, any three things. So what we are given in these four cases is three things: angle, side, side, angle, side, side, angle, side, side, angle, side, side. Do you see that? So we have enough information to solve these triangles if a triangle can be formed. That is first thing to understand. Now, what are the cases when triangle cannot be formed? What are the cases when we get only one triangle? And what are the cases when we get two triangles? Let us understand that also before getting into it. Now, we could have obtuse angle as given here in A. So we could have two cases, one obtuse angle, the others with acute angle. Correct. Now, if you are given obtuse angle, no, if you are given obtuse angle which is more than 90 degrees, then clearly the side opposite to the angle should be longest, correct? So if I say that this angle here is an obtuse angle, then we know that this side A is longest. Perfect, because that's an obtuse angle. Other angles are very small, right? So A is the longest side. Let me name this triangle as ABC, okay. Now if I look into part A, which is an obtuse angle, side A is 8.9, but B is 9.2. Now since A is less than B, triangles cannot be formed. So we can write 0 triangles. Is it okay? 0 triangles. Because if A is an obtuse angle, then the side opposite to A should have been the longest. Since that is not the case, we cannot form a triangle. Done. Do you see how simple it is? Now let's look into acute angle cases. So if I draw a triangle which is acute angle triangles, let me make one here, let's say kind of like this. Then in acute angle triangle, we'll always compare the side with the altitude. That is the concept, okay? So let me label this triangle also ABC. This side is A, that is B, that is an altitude. This angle, let's call this as theta. In that case, what is height equals to? In that case, height is equal to B sine theta. B sine theta, correct? So height is B sine theta. Now, it depends on the value of A. If it is greater than H or less than H, what is the case, or is equal to, right? Then we can form different kinds of triangles. Now here there are many cases. So we have actually three cases in this particular case. One is that in an acute angle, let me write down three cases here, right? We have three cases. So first case is if we are given acute angle and if side A is actually greater than side B. So if A is greater than B itself, then we have only one triangle, right? So this is too long, like shown here. So if I go this side, no, I cannot make a triangle. That angle doesn't fit in. I have to go somewhere here only. So if A is greater than B, let's look into the second example, which I'm trying to say. Second example is angle A is acute 15 degrees and B is 3.8. So B is 3.8. And what we see here is that A is greater than B. Now in this case, we can make only one triangle. So like shown here, do you understand? Only one triangle, and we'll calculate all the values of this triangle, because second part is solve the possible triangles. We'll do that. So that is first case. The second case is that A could be equal to H. So if A is equal to H, then also you have one triangle, but this triangle is a right triangle. Is it okay? This triangle is a right triangle. And the third case is that A is actually greater than the height, but is less than B. Now in that case, let us say something like this. Let me sketch. Let us say A is greater than height. That means it's longer than this, right? Longer than this, kind of this much. In that case, we can form two triangles. Do you see that? These are the two triangles which can be formed. Correct? So we have two triangles if A is between height and this. Correct? So that leads to two triangles. The last case here is that A is less than height. So if A is less than height, in that case we cannot form any triangle, since then it is very short and it cannot reach here, right? So if let's say A is only this much long, then you cannot form a triangle, as you can see here, right? You cannot form a triangle. So let's get to these examples again. 7.73 degrees, A is 8.5, and this is B. Let me correct this, B, typing error. So let's find what is B sine, which is, what is B sine theta? Now B sine theta will be 9.2 sine of 73 degrees, correct? Let's calculate this value. 9.2 times sine of 73 degrees is equal to 8.79. Now 8.79 is my height. This is equals to the height. Now since A is only 8.5, right? So A is actually less than height. It is this case. So in this case we have zero triangles. So we have zero triangles here. We got one triangle in this case, and we got zero triangles here. These are number of triangles we are writing. Is it okay? Now the last case here is 41 is the angle, 6.5 is the value of A, and B is 9.2. So let us now again calculate 9.2 sine of 41 degrees. What do we get? So if I do 9.2 times sine of 41 degrees, I get 6.03. Now clearly 6.5, that is A, is greater than 6.03, so we can form two triangles. So in this case we have two triangles. Is it okay? So we get two triangles in this case. Is that clear? So that is how we decide how many triangles can be formed. Now we do have two examples where the triangles are being formed. Now let us solve these two triangles. So the first case here is when we are given the angle of 15 degrees and the side A is 7.3, pretty long, right? And B is 3.8. So let's form this. So let's make a triangle which is kind of like this. 15 degrees is, let's say, like this, and then let me make this as 7.3. So sides are ABC for us. Angle is 15 degrees. Side opposite is 7.3 and B is 3.8. Now in this case, to solve for b, we can use sine law. So sine of b over the side 3.8 is equal to sine of angle A, which is 15 degrees, over 7.3. So we can say sine B is equals to 3.8 times sine of 15 degrees divided by 7.3, right? Now we can calculate this and then find angle B as sine inverse of all this, 3.8 over 7.3 times sine of 15 degrees. Is it okay? So that is how we can find angle B. Once we find angle B, we can find all other things also. So let's calculate first this. We have 3.8 times sine of 15 degrees. We'll divide this by 7.3. Whatever we get, which is let me write down here, 0.1347, we'll do sine inverse of this. So shift sine inverse of the answer is equal to 7.742. So we'll write let's say 7, right? Let's go for 1 decimal place. So we round it to tenths. So we know this angle is 7.7. Now you can find angle C very easily. Angle C is equal to, sum is 180 degrees. So it is 180 degrees minus 15 minus 7.7 degrees. Is it okay? So let's calculate that. 180 take away 15 take away 7.7 gives you, in decimals, 157.3. So it is 157.3 degrees. So we got the angle C, which is 157.3. Now we can find the missing side AB, right? So let's do that. Missing side AB can be written as, again, sine law. AB divided by sine of 157.3 should be equal to what is given to us? The combination 3.8. Let's use the combination that, okay. I should have used 7.3. Okay, better is we are given 7.3 and 15, we'll use that one because there is an error here, right? So we'll use 7.3 over sine of 15 degrees since that is given to us and this is approximate, right? So AB will be equals to 7.3 over sine of 15 degrees times sine of 157.3 degrees, right? So this is a pretty long side. 7.3 times sine of 157.3, and we'll divide this by sine of 15 degrees, which is equal to 10.88. So I'll round it to 10.9 units. Is that correct? So that is how you could solve this particular triangle. So I hope it is absolutely clear. So first we tested it out and we found that this was a case of acute angle in which A was greater than B itself. So there's only one triangle. Now let's go to the other case where we found there are two triangles. So in this case we have a acute angle where side A is between height and base, right? So let me sketch this triangle here. Now we could actually get this side kind of like this, where these two sides are equal. So that is the case, right? So we have sides A, B, and C. Angle A is 41 degrees, and side opposite is 6.5, and this side is 9.2. So what we figure out that angle A, which is 41 degrees, is an acute angle. So we calculated B sine theta, which is the height, and that is 9.2 sine of 41. Let's redo it. okay, no harm. 9.2 sine of 41, and it gave us 6.03. Now since the side A is greater than 6.03 and is less than 9.2, right? We know sine A is 6.5. We have a case of two triangles. So that is the case, right? So this side is also 6.5. Do you see that? Now, we know the situation. Let's find angle B using sine law. So sine B over side 9.2 should be equal to sine A, which is 41 degrees, over the given side 6.5. So sine B is equal to 9.2 over 6.5 times sine of 41 degrees. Let's calculate. So it is 9.2 times sine 41 divided by 6.5 equals to 0.9285. So angle B is equals to sine inverse of 0.9285. I'll use the value in the calculator. Shift sine inverse, answer equals to 68.2, rounded to 68.2 degrees. Right? So what we get here is 68.2. Now, so we have two triangles. So let's first solve the big triangle. So in big triangle, angle C is equal to 180 minus 41 minus 68.2. So let's do this. 180 minus 41 minus 68.2 is equal to, in decimals, 70.8. So in big triangle, this is 70.8. And let's find what AB is. So we'll find AB as AB over sine of 70.8 is equal to this ratio, which is 6.5 over sine of 41. So AB is equals to sine of 70.8 times, let's write, sine of 41 times 6.5, right? So let's do it. So we'll first find sine of 70.8, right? So sine of angle, okay, and then we'll do times 6.5 and then divide by sine of 41. So we get this equal to 9.35. So this is 9.35 rounded to 9.4 for the big triangle. Now what you can do is you can now solve the smaller triangle, which basically is this one, right? So which is basically this triangle, right? Now the angle here should be how much? 180 minus 68.2, right? Calculate this. 180 minus 68.2, that gives you in decimals 111.8. So that is the angle here, right? Now if this is the angle, in that case, what is C dash? Let me now call this as C dash, right? So I'm making this triangle as A, B dash, C dash, right? So we have B dash as equal to 111.8, okay. So angle C dash is 180 minus 111.8 minus 41, which is in decimals 27.2 degrees. Is that okay? So very small angle, which is 27.2 degrees. And we know the side is 6.5. We need to find now AB dash. So AB dash will be now equal to sine of this angle, right? Sine of this angle, which is sine of, earlier it was 70.8, now it is 27.2 divided by sine of 41 times 6.5, which is this side. Is it okay? 6.5. So let's calculate. So it is sine of 27.2 times 6.5 divided by sine of 41 equals to 4.52. So we'll write 4.2. Is it okay? So it is 4.2. So this is the second triangle. So we find that in this particular case we do have two triangles. So that is case 1 and this is case 2. Right? So that is how you could solve both the cases. So I hope with this example you understand that while solving triangles with given information, there is a possibility of not having any triangle or having one or two triangles, as we saw in this particular video. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe my videos, that would be great. Thank you and all the best.